Right. Hey, ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 6, Notes 4. So we're going to be talking about exponential decay. Exponential decay is really very similar to exponential growth, except there's going to be a minus sign. So let's go ahead and let's take a look at the equation for exponential decay. So we're going to have y is equal to c times the quantity 1 minus r raised to the t power. Now, a lot of students make the mistake of just putting r in the parentheses when they do exponential decay, but you do need to have the 1 minus in there. Okay, so it's really the exact opposite of growth. Instead of a plus, it's a minus, and then everything else is going to stay the same. The c is still the initial amount, the r is still the rate of change, and the t is still the time. So let's go ahead and let's start by taking a look at this first problem here. So we're going to go ahead and write the equation. So I'm going to have y is equal to 16 times 1 minus 0.45, and that's going to be raised to the x power. Now I like to actually go through and subtract it out, because then each time I type it in, there's just that much less I have to actually write. So it's going to be y is equal to 16 times 0.55 raised to the x power. So now we're going to go ahead and fill out this chart. Now when I do exponential decay, I actually like to start my chart at -1, and then I do 0, 1, 2, 3, and 4. Okay, so really all I'm doing is I'm plugging that in for the exponent. So I have 16 times 0.55 raised to the x power. So my first one would be raising it to the -1 power. Well, that's going to give me 29.9. Okay, then raising it to the 0 power, I end up getting 16. Raising it to the 1 power, I'm going to get 8.8. And then raising it to the second power, I get 4.84. Raising it to the third power, 2.66. And then raising it to the fourth power, 1.46. So now we're going to go ahead and graph that. So -1 going up 29. Well, 29 is off our graph, so I can't graph that point. Then we're going over 0 up 16, so I'm going to go ahead and plot that point. Then we're going over 1 up 8.8, so we're going almost all the way to 9. And then we're going to go over 2 up 4.84, so we're going almost all the way to 5. And then we're going over 3 up 2.66, so that's going to be just over halfway to 3. And then we're going over 4 up 1.46, so that's going to be 1.5. So then this is going to go ahead and it's going to slope downwards. So that right there is going to be our graph. Okay, keep in mind I don't want to cross that x-axis. I'm going to come down and I'm going to land and I'm going to touch it, but I'm not actually going to cross that line. So be aware of that as you're looking through these. So now let's go ahead and let's take a look at number 2. Okay, so for number 2, I'm going to go ahead and write my equation. So it's going to be y is equal to 15 times 1 minus 1/3, which I'm going to just write as 0.33, and that's going to be raised to the x. So then when I actually go and subtract that, I get that y is equal to 15 times 0.67 raised to the x power. So I'm going to go ahead and calculate that. So I'm going to do -1, 0, 1, 2, 3, and 4. So then, again, I'm just really plugging that in to get my y. So then I have 15 times 0.67, and that's going to be to the -1. Okay, so then when I do that in my calculator, again, I always suggest you do it along with me to make sure you're getting the right answer. I get 22.39. Then I'm going to plug in 0, so 15 times 0.67 to the 0 power, and I get 15. Okay, 15 times 0.67 to the first power, I'm going to get 10. Now, when you're doing exponential decay, it should always be going down. So 15 times 0.67 to the second power, which is 6.73. Then I'm going to do 15 times 0.67 to the third power, and I get 4.5. And then 15 times 0.67 to the fourth power, I get 3.02. Okay, so now let's go ahead and graph that. So we're going over 0 up 15, so we're going to plot that point. Over 1 up 10, so that's going to be that point. Over 2 up 6.73, so we're going to go up 6 almost all the way to 7. Over 3 up 4.5. and then over 4, whoa, apparently I highlighted it, over 4, up 3, and just past 3 at 0.02. So now this is going to be sloping downward. Again, never crossing that x-axis. You can cross the y-axis, but you cannot cross the x-axis, which is the horizontal one. So now let's take a look at some word problem setup. So taking a look at this one, it says a fully inflated raft loses 6.6% of its air every day. The raft originally contains 4,500 cubic inches of air. Write an equation to represent the loss of air using the general equation for decay. So let's go ahead and do that, okay? So y is equal to, now we're starting out with 4,500 cubic inches of air. So I'm going to go ahead and write that. And then we're going to do 1 minus, so then I have 6.6. So what I'm going to do is I'm going to convert it to the left. You never want to put a percentage in there. So to go from a percent to a decimal, you move it left 2 places. So 1 minus 0.066 to the x power. So then I like to actually go through and subtract this. If you forget on a quiz, I won't take off points, but I do like how it looks when it's all nicely subtracted, because I don't know about you, but I love me just a pretty number with no signs in it. Okay, so now we want to estimate how much air will be lost after 7 days. So x is going to represent the number of days. So to figure that out, what I'm going to do is I'm going to take x out, and I'm going to put 7 instead to estimate that for b. So in my calculator, I'm going to do 4,500 times 0.934 to the 7th power. And if you have a good calculator, if you type it in just like that, you should get the right answer. So check it. Make sure you're getting the same answer as me. I got 2,790.23. Since we're talking about cubic inches of air, you can have a decimal. So I'm going to put inches cubed on number 3. All right, let's take a look at number 4. During the past several years in Campbell County, Kentucky, has been decreasing at an average rate of about 0.3% per year. In 2000, the population was 88,647. Write a decay equation that represents the population since 2000. Then, if assuming the same trend continues, estimate the population in 2013. So let's go ahead and let's do this, okay? So when I have 0.3%, a lot of students think that 0.3 is their answer, but it's a percent, so we actually still have to convert the decimal left 2 places. So this is my R. So I'm going to have y is equal to our 88,647 times 1 minus 0.003, and that's going to be raised to the x power, or apparently to the box power. So we're going to get that y is equal to 88,647, and then 1 minus 0.003 is 0.997, and now that's going to be raised to the x power. So it asks us to figure out what the population is going to be in 2013. So let's go ahead and do that. So what we're going to do is we're going to take away the x. Between 2000 and 2013, there's going to be 13. Okay, so now we can go ahead and calculate that out. So 88,647 times 0.997 to the 13th is 85,251 people. Okay, so let's take a look at number 5. It says, during an economic recession, a charitable organization found that donations dropped by 1.1%. Before the recession, here are our donations. So we're going to start, we have 390,000 times 1 minus 0.001, or 0.011, again, moving it left 2 places. Then we're going to take that and raise it to the x power. So now what we're going to do is we want to figure out what the charitable death was after 5 years. Whoops. So now I'm going to take this out and I'm going to put 5 in instead. So I'm going to get 390,000 times 1 minus 0.011, and that's going to give me 0.989, and that's going to be to the 5th power. So now we're going to go ahead and we're going to type that into your calculator. Remember, I always suggest you do that with me. So then what we're going to do is we're going to get this answer right here. So $369,016.74. So it's always good to be checking that answer with me to make sure you're doing it correctly. Last but not least, we want to determine if something is growth or decay. You know it's growth if the thing that the x is being raised to, so the number that the x to the power is to, if that's 1 or greater, then it's growth. So I'm just going to put a G for growth on that one. Here, 2/5 is being raised to the x power. Well, that's less than 1, so this one's going to be decay. Here, this 0.75 is what actually is being raised to the x power, not the 2. The 0.75 is. So that makes this a decay. Here, the 4 is what's being raised to the x power, not the 1/2. So since it's the 4, it's going to be growth. And here, since it's the 5, it's going to be growth. Okay, so that concludes your note video for today. Please let me know if you have any questions. Thanks for listening.